Welcome to solving systems of equations with two variables using a calculator. The calculator I will be using for this demonstration is a TI-84 plus CE. I think any TI-84 would do just fine, but this particular one makes the different graphs in different colors and make that adds a little bit ease in the second example. Linear and nonlinear equations can be handled easily with a graphing calculator. So we now have to restrict ourselves to linear equation. So this should suffice if you're in up to college algebra, where you're actually solving systems of nonlinear equations. Everything should work out. If you have more than two variables, let me just tell you that there is a technique that your calculator easily handles, and we will have that in another video. So a graphing calculator gives a visual when solving a system of equations. To take advantage of the graphing calculator's ability to solve a system of equations, first isolate one variable and we'll select y on one side of each equation. This is important. So you want your calculator to isolate a variable, and y variable is usually the one that we would be using and associating with a function. Your calculator works with functions. Let's start with a simple solution of equations and get acquainted with the process. So we're going to solve for xy, an ordered pair. The system of equations, 2x plus 3y equals 6, and 3x minus 2y equals 12. So the first step is to solve this system is to isolate y. Y equals 6x minus 2y over 3, and y equals 3x minus 12y over 2. Well, these strange looking parentheses, fraction, and so on. Before you go through the trouble of simplifying, let me just say the calculator don't care. So we don't have to make it look nice for the calculator. So the first thing we want to do is get the two expressions in for y. So add the two expressions into your calculator, one for y1 and one for y2. The calculator does not need you to simplify anything. So just type them in. Y1 equals, that will all be there. Just start at the parentheses and type. You start here at the parentheses and type. Next, we're going to type second calc, and that's the shift of the trace key, and select number 5, the intersection. So this is the screen you will see, second calc, and you're going to select number 5 right here. You will be asked to identify the two curves and to provide a guess. The calculator can hold more than two equations, and it does not realize you want to only only two equations desired. It don't know. And so you might have equations 1, 2, 3, 4, 5. You might want to intersect 1 and 5. So it does not really know that. You're going to have to tell it. Even when there's only two, you say, well, it should default to those two. No, it will not. The guess is to get the process started close to the intersection needed. There can be several intersections for nonlinear equation. So here we see where the intersection is going to be. So when I start off, it's going to ask me for the first curve, and there'll be a little blinking symbol right here. Well, that's one of the curves I'm interested in, so I'm going to hit enter. Then it's going to go to the second curve, and leave that one more. I've selected it, and this will be blinking, and I'm going to hit enter. And then it's going to ask me for a guess. Now, it would like to converge down to this, so I don't want to make a guess too far out. With straight lines, it really don't matter. But if these weren't straight lines, I would want to get close enough that I can converge to that intersection. And so it gives me a guess, and the guess happens to be wherever the cursor was left. That's fine. If it's not, move it with the left and right arrows. The cursor will immediately go to the solution right here and give the answer. The intersection is x equals 3.692387, y equals negative 0.461538. So it don't care how messy or how many the fact that there's many decimals, it's going to give you an answer. So a graphing calculator can only handle functions. So it may be necessary to break expressions involving y squared, for example, into more than one function. If a circle, such as x squared plus y squared equals 4, is to be intersected with a curve, such as y equals 1 over x, solving the equation of the circle for y produces two functions. So if I isolate y squared, I get 4 minus x squared, and I got to take the square root. When I take the square root, I get two answers. I get y equals the square root of 4 minus x squared, and y equals negative the square root of 4 minus x squared. This would be the semicircle above the x-axis, and this would be the semicircle below the x-axis. So I have two different functions to load into my calculator just for this. And then I also have the third function. So find all points of intersection of the circle x squared plus y squared equals 4 with the hyperbola y equals 1 over x. So first load in the functions into your calculator. Y1 is the square root of 4 minus x squared. Y2 is negative 4 minus x squared. And Y3 is 1 over x. And realize we're never going to intersect Y1 with Y2. We're going to be looking at where does 1 over x intersect Y1 and where does 1 over x intersect Y2. So here's what your screen should look like. You have the three functions loaded. And the top one will graph blue, the second one will graph red, the third one will graph black. If you don't have the plus CE, you may be getting all black graphs, which is fine, as long as you can keep track of which one is which. So then we're going to go look for the intersection. We're going to go to second calc, which is the shift of the trace key, and select 5 again. Now we're going to have to answer the three questions. First curve, second curve, and guess. Here, first and second curve refer to the two curves with the intersection being sought, not y1 and y2. So we might select y1 and y3 as first and second, or we might select y1, y2 and y3 and put on first and second. Also for y3, observe the function is not defined for 0, x equals 0. So that is an inappropriate guess. Get it off of the place where it's not defined, and actually make certain you go to the side of the origin where the solution is located. So move the cursor to the right and define the intersection of the blue, which is the top semicircle, and the black curves before making a guess. So we're going to just use the arrow and move it over. So we're going to have to answer those three questions. First curve, we're going to select y1. Second curve, we're going to select y3. Now, here are the four solutions. The first one is going to be right here at x equals decimal 5176381, y equals 1.931851. Realize that if I go too far to the right, I'm going to end up finding this solution, which is here. And if I select top curve and the bottom curve, y1 and y3, if I'm close to this solution, I will get this one. If I'm closer to the other solution, I'm going to get this one. I believe that it's not quite the distance. I think that it goes by the gap between the two curves coming together. So in other words, if on one end they come together very rapidly, you want to get real close to that solution. If they come together slowly, you got a little more latitude. But try to pick good starting points. If you go back to the same solution, get it closer to the other solution, or maybe even if you've got the space and you're not at the edge of the graph, go to the other side. That would be a good way to get to the second solution. So solving systems of equations with more than two variables will be handled in another video. We'll be using the Gauss-Jordan technique, which a calculator has already programmed in. And the problem with that technique is it does not handle nonlinear equations, but we can expand to 3, 4, 5 variables and find these solutions. Thank you for viewing this video. There are others and more are coming. So please subscribe to the channel so you do not miss any. They will be coming out pretty quickly. Thank you.